for letter A? How many groups have a hypothesis for letter A? We started this warm-up a little bit earlier. Tried to give you guys some ideas. Yeah, Andrew?
I got lowercase b.
Yeah.
Lowercase b.
Yeah, there is. It's
Sorry. Yeah. He's going this way. Okay. So yeah, for capital A it goes with lowercase b. Does anybody have one for lowercase a?
Oh.
Yeah. C? How do we test whether or not she's right? And some of you, how many of you guys agree that you think it's C? Okay, cool. Like half the class kind of figured that out. Letter C, what's a good hypothesis? And Jerry, I saw you raise your hand. Did you have like a number that you thought C was almost?
Yeah.
Yeah, what do you think it was almost?
2.1.
2.1. So if we took C and if we took 2.1, question, according to this index, how many times am I supposed to multiply 2.1?
4.
Good. So if you figured out that cool caret button, you could just do it to the power of 4, that cool exponent button. Or we can multiply 2.1 times 2.1 times 2.1. Did it end up being about 25? Yeah, that was a good match. How about lowercase d? Who has a match for me for lowercase d?
I got one.
You got one? Andrew, what do you think it is?
E.
Okay. Do you, oh, well, that's probably.
Hold up, whoa, I'm so confused, hold up. So like the one to the left of that one, the D, the uppercase D, is lowercase e.
Okay, so because we only have 2 left, right? So he's thinking this and this, right?
Yes.
Yes.
Why does that make sense, even without going to a calculator? Now, some of you might have done this E is about 4, and done 4 times 4 times 4, and realized it was 64. Some of you could have made that match. But do you guys realize what's the same for both of these?
The thing.
5 and the power.
Well, there is a 5 at the end, and then the radical, the root itself. They both had an index of 3, which means we're looking for groups of 3, right? So which one is going to give me the bigger number? E, the higher one, right? And which one's going to give me the lower number? Since they're both groups of 3, we're like, oh, hey, the higher one will give me the 65. The lower one must give me the 55. But if you guys put it in your calculator and you did it in a group of 3, hopefully you saw that also. Hopefully. Okay, last night, let's go to our homework. Numbers 1 through 10. Wasn't this hard, right? Now, around 7, 8, 9, 10, it got a little weird.
Yes.
7, 8, 9, 10 got a little bit harder. But can we go ahead and grade the evens real fast? Because not everybody knows the answers to those evens. Okay, where were we? We were section 6.2. Let me put my marker down. Don't worry, 1 through 60 is way more than you guys had to do. You only had to do, don't worry. 2 through 10 is right here. You have to grade 2 through 10, right? So 2, 4, 6, 8, 10, because 1, 3, 5, 7 was in the back of the book, yeah?
Yes.
Yeah, it was page 306. Good.
Yes.
It was page 306. And remind me that. Yeah, they did your homework?
No.
It was on red line.
Page 306.
Make sure you show me.
Yeah, you guys can show me a link either at the end of class or the end of the day. And then, Daniel.
I don't really feel like it.
Bro.
Question for me? Yeah, it got tricky there at the Thanks for showing those question marks. That was good.
Right now.
I saw that you were working. I'm not sure I would take Yeah, the homework's on the board if you guys want to write it down for tomorrow. Some of you found an earlier assignment last week. The nice thing is, we shouldn't have any homework assignments that change this week, which is good. Last week, you guys noticed that we slowed down, and so a few things got kind of off, but now it's good. Okay, I have this up here, guys, so that we could go ahead and you guys could grade, and if you had any questions, you could let me know. I saw when I walked around the room, some people got kind of confused right around 7, 8, 9, 10.
Oh, I got it.
It's right up back here on the board if you guys want to write it down. Your homework is back on the board if you guys want to write it down. A few of you that got behind tonight for homework, you can do 1 through 10 and the next homework assignment, and then you can show me tomorrow when I walk around. I can give you the late credit on the other one and full credit on the new one. What was going on in 3 and 4? Good. Taking it from, what form is this called if there's one of these guys? Radical. Good. You're going from radical form to
Rational.
Yeah, to rational exponent form. And then in this one, there are rational or fraction exponents, and you're supposed to be taking it back
Radical
to.
form.
Yeah, so this one you were going to exponents, and this one you were coming from exponents to radicals. But it got a little bit harder right around 7, 8, 9, 10, right?
Yeah.
For a few people. Sorry, as I walked around the room, I noticed that. Because what was going on in 7, 8, 9, 10, for those of you that didn't get stuck, how did you do these problems? Because a lot of the class did get stuck, or at least it got harder for them. What were the directions asking of you guys? Nth roots. Yeah, nth roots. So for instance, for number 7, for all of you guys that got a little stuck, or for those of you, there was like 1/3 of the class that didn't do homework. For number 7, what kind of root does this 2 say?
2.
Square root. So you could write the 2 in there. It actually doesn't need to be written. It's an understood 2. But what's going to go underneath is the 36. So every single one of these problems is leading us to a radical or leading us to a root. So guys, how would you rewrite number 8? What would have been in the radical? 4. And what would have been underneath?
81.
Okay, now you weren't supposed to stop there though. So from what we did just now in our warm-up, we're looking for a number that in a group of 4 would make 81, right? Or we're looking for a number in a group of 2 that would make 36. Do you guys know something times itself that makes 36?
6.
Yeah, 6 times 6. So what's the square root of 36?
6.
Okay. But, this one we're looking for a group of 4, which is a little bit harder. Now, do you guys know that 9 times 9 is 81?
Yeah.
So that's only a group of 2. So that would be a square root. We have a 4th root. So then I'm hearing a couple people be like, hey, look at 3, because can't 9 and 9 both go down to 3 times 3? So I could rewrite 81 as the 4th root. I don't want to keep the 9 times 9. That's not enough. But 3's, group of 4, 3's makes 81. So what's my final answer?
3.
So when you're answering a radical question, you're answering a group of 4 of these makes this number. A group of 4 3's makes 81. Or a group of 2 6's makes 36. So can we go to one of these other crazy ones? How would you rewrite number 9 as a radical? What goes in the radical?
3.
So I'm looking for a cubed root or a group of 3 to make 1,000. Does that work? Because 10 times 10 is 100. Another 10 would make a, oh, nice. You guys seeing how these are working?
Yes.
Now, this got really messy really fast. So we're going to do number 10, but he has a crazy 9 in there. We better erase all of this. And most of you either got stuck on number 10 or at least realized that number 10 was probably one of the hardest ones. I'm going to erase all this so that there's room. But as I'm erasing this, look at number 10's problem. What kind of radical am I looking for? Which root?
9.
A 9th root. So we're looking for something with a group of 9 of them. Oh, dang. When we did our warm-up, you guys realized that 6 5-point-somethings made like 20,000. Huh. So we're looking for 9? Let me go back to my pen real quick. The 9th root. The 9th root of negative 512. Okay. Now, even though some of you might have figured this out for homework, can we just admit something real quick? There are not many of us that could be like, oh, got that off the top of my head, here you go. Because it's 9 of them. 9 of them multiplied together. Does anybody even know what 2, one of the most easiest numbers ever, 2 to the 9th power is?
No.
Right? The 9th power, we're not used to that. 2 squared, 3 squared, 4 squared, but not to the 9th power. So what if we were to do that factoring thing that we talked about on Friday? Some of you like the tree.
Yeah.
Some of you like the box. I've done the tree a couple times now. Can I do the box just for
Yeah.
the illustration? Do you guys realize it's an even number, so 2 is going to go in?
Yeah.
Okay. Now, some of you have your calculators. Others of you know how to do like long division with the 2. I know how to do long division kind of in my head. So I know that 2 goes into 5 2 times. Carry the 1. 2 goes into 11 5 times. Carry the 1. 2 goes into 12 6 times. But you could also double check me in your calculator. 512 divided by 2 is this number. Now what if I divide by 2 again? 2 goes into 2 1 times, 2 times. You guys could do it in your calculator. It'll be 128. Can 2 go in again? Well, I'm going to keep doing this all day long as I can. Now if I keep dividing, I'm really good at dividing, sorry. So I'm doing it fast. But you guys could do this in your calculator, right? Divided by, divided by, divided by, divided by. 16 divided by 2. Wait, we all know that. 16 divided by 2 is 8. 8 divided by 2 is
4.
4 divided by 2 is 2 divided by 2 is
1.
Okay, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8.
9.
But why would it be a negative, Isaiah? You're totally right. It needs to be something that, oh, there was a negative. So if I divided by a negative, what do we got in a positive? Divided by a negative, divided by a negative, positive, divided by a negative. I could throw negatives, and if you guys had followed it, yeah, it's negative 2 grouped together 9 times. Negative 2 grouped together 9 times. We could have kept going. You would have had negatives along the way, but there we go. So that was probably the hardest one. So guys, can we get back to our notes? Because we didn't get to write down in our notes a couple things that we've seen today. All right? So on Friday, a few of you guys, I told you to get some colors out because we were going to color code a few things. And we did, especially up here in the very top. Because you've heard me today use the word index a lot. It was something that we wrote down in our notes on Friday. So notes open. Show me that. And even in your homework, this could have been helpful, right, guys? Because in your homework, in some of the directions, it said, get it into radical form. If you looked in your notes, you would have seen, oh, a radical is that root sign. Or it said, get it into rational exponent form. And so you're like, oh, get it to look like this. So you have the rational exponent side, and you have the radical side. You have these bases that are the numbers that get multiplied together. And then you have the index that says, actually, you know what would be helpful for probably a lot of you after what we saw today? Remember how I kept on saying group of? A group of 2, a group of 3, a group of n. So maybe some of you underneath the index or underneath the root, maybe you should write group of, because that might help your brain as far as what or how to use this, okay? So for this one, we were looking for what group of 3 would multiply together to get 64, or the snazzy way of saying it, what is the cubed root, or the third root of 64. So we wrote down steps on Friday, but we didn't get to do a lot of examples. But nice thing is, just by going over homework, and by even doing the weird estimation thing at the beginning of class, I think some of you have the idea of group of down a little bit more. So we rewrote a radical form in a rational exponent form, and we rewrote a rational exponent form in a radical form to help you off with homework to know basically how to start homework. But we didn't get to do some of those examples like I wanted to talk about. We're going to skip that page for right now. So let's try a couple more, kind of like what you guys just saw in your homework. Let's try a couple more, kind of like what you guys just saw in your homework. So how would you rewrite this problem, guys, if it says n equals 3 and a is negative 125?
Put the 125 inside.
Inside what?
Thingy.
What's it called? Well, it is a square root if there's a 2, but this one has a 3, so we technically would call it a cubed root, or we could call a radical with a third root. But what else do we need underneath? A negative. So guys, we're looking for a number times itself. Because of that negative, we know each of these has to be a negative. All right, guys, so we're in notes. Section 6.2. We're doing a couple of notes. Now, we could throw a 1 in there. 1 times 1 times 1 is still 1. That's way too small. We could throw a 2 in there. 2 times 2 is 4. 4 times 2 is 8. I think there are a few of you that see this 125, and if you were doing the factoring tree, I bet that you would divide it by 5 and realize there's a 25 left over. And then if you keep dividing 25 by 5, what ends up being the cubed root? If we're just looking for a group of 3, negative 5. Do you see how when we find that group, the radical leaves and we're left with that final answer?
Yes.
Now we could go ahead and do this 6th root of 64. We could go ahead and do the 6th root of 64. And I could do a factoring tree, but you guys know what you would end up finding? Well, I ran out of space. You're going to end up dividing 64 by 2 and by 2 again and by 2 again and by 2 again. And you'll end up figuring out that there is a group of 6 2s that make 64, which means the 6th root of 64 equals that 2. So developing that idea of grouping. But guys, you're going to start seeing in tonight's homework not ones that you have to build the notation or build the problem, but ones that are already written in that form already. So would you know what to do if you started seeing them already in the radical forms or already in the exponential rational forms? Jerry, I see you have a question, just because time is short. Ask me right after class, okay? Now, I'm giving you kind of smaller numbers, but what should you do when you see the bigger numbers in homework? Maybe a calculator and a factoring tree, right? Break down those big numbers so you can see what they are. But do you guys see how, for each of these, you would be looking for groups of what?
3.
And I know these are written weird, but what would you be looking at for this one? Groups of 4. And couldn't you rewrite this as a radical first to make it look a little bit more normal? Now wait a minute, where'd the 1 go?
The 1 is still there.
The 1 is still there, it's just understood, right? And the same thing here. Now this one's actually telling you to watch out for signs with the negatives, but we'll see tomorrow how you guys do in the homework when we grade as to whether the negatives got confusing or whether you were able to keep up with the negatives. But what's way more important than the negatives right now is that you look at either a radical or a rational exponent and notice what groups you're looking for, and then you break down the numbers and find those groups. Does that kind of make sense, guys, what radicals are?
Yes.
Let's see House Nice homework. You take a picture of it on the way out the door. It is already on RedWeb because I know where we're going this week a little bit better than last week. Levi and Andrew.